I am Pavan Reddy. I am here to present my internship project titled IoT-Based Home Automation Solution. This project was completed as part of my 4-week internship at Emergy Information Technologies, which is located in Bangalore. It is a leading institute in embedded systems and IoT training. Through this presentation, I will explain the concepts I learned during internship, the tools I use, the design and working of my project, and finally I will give live simulation to demonstrate the functionality. Let me tell about the internship. The internship is, before going to internship, we have what are the in this presentation what we discuss about, which contain the table of contents about the internship, topics I learned in the internship, what is IoT and embedded systems, and programming languages like C++, and about the project, implementation of the project, and finally conclusion. About the internship. The internship at Emergy Information Technologies was structured, hands-on learning, and a experience. It focused on helping students like me understand the core concepts of embedded systems and IoT by combining both theoretical and also practical implementation like projects. It is duration of 4 weeks, during which we followed a well-organized weekly plan with regular evaluations. Learning materials was provided through the Moodle LMS platform, which made it easy to track progress and access study resources. The sessions including coding exercises, hardware simulation, and project assignments that helped us build both programming and problem solving skills. We also had a great mental support, and the internship emphasized project based learning, which made the experience were engaging and effective. And topics covered during the internship, I covered a wide range of technical topics that are essential for the embedded systems and IoT development. In the learning phase, I gained knowledge of C and C++ programming, object-oriented programming concepts, embedded system architecture, and IoT fundamentals also. In project phase, I worked on Arduino programming, peripheral interfacing, simulation using PICSimLab, and IoT application integration using the Blynk mobile app. This combination of hardware, software, and cloud learning helped me build a complete understanding of how IoT systems are designed and implemented. Before going into the project details, let me briefly explain about what is IoT is. IoT or Internet of Things is concept of connecting physical devices to the internet so they can collect and exchange data. Each device in an IoT network can sense, process, and communicate with other devices or cloud platforms to make intelligence decisions automatically. The IoT system includes multiple layers, device that is devices and sensors, network connectivity, cloud servers for data storage, user applications, and security protocols. A well-designed IoT system ensures real-time monitoring, automation, and remote accessibility, which are the key goals of home automation. Yeah, we already discussed about the ecosystem, which means the components of IoT system, which contains IoT devices, network, security, gateway, the cloud, application, and users. And let me discuss about something about embedded system. An embedded system is a microcontroller based computer system designed to perform a specific task or dedicated function. It combines hardware components such as sensors, actuators, with software written specifically for the task. Here, sensors are the output devices and actuators are the input devices. For example, washing machine, digital cameras, medical monitoring devices are all embedded systems. IoT extends the concept of embedded systems by adding connectivity. That means allowing devices to communicate through the internet. Hence, we can say embedded systems from the backbone of IoT. Yeah. An embedded system and IoT, which here it consists of, you see the cursor, embedded system, which consists of IoT device, IoT gateway, internet, cloud, and applications. This whole combined called as Internet of Things. Yeah, let me discuss about different types of embedded systems. Embedded systems can be classified into four major categories, which are real-time embedded systems, standalone embedded systems, networked embedded systems, and mobile embedded systems. Here, real-time embedded systems such as flight control system or vehicle safety units, which needed instant responses. Yeah, then standalone embedded systems like calculators, digital watches that work independently. Then networked embedded systems such as ATMs, home security systems that depend on network communication. Next one is mobile embedded systems like smartphones, smartwatches, which combine mobility and processing power. Yeah. These examples show how deeply embedded technology is integrated in our daily life. Then here are some examples like smartphone, smartwatch, and some medical equipment, robot, car, camera, landline phone, yeah, washing machine. These are some of the examples of embedded systems. Then a strong foundation programming is essential for embedded development. During the internship, I worked extensively with C and C++. In C, I practiced topics like loops, conditionals, arrays, pointers, file handlings. In C++, I learned object-oriented programming, which includes classes, inheritance, encapsulation, abstraction, and polymorphism. These skills helped me write efficient, modular, and reusable code, especially while programming the Arduino in this project. Through continuous practice, I improved my ability to debug and optimize embedded code for real-time performance. Yeah. Then about this project, let me introduce my project titled IoT-based home automation. Yeah, the main goal of the project is to create a smart home environment that automatically can control devices like garden lights, temperature system, and water tanks. The system designed to provide energy efficiency, automation, user convenience, and remote access through IoT. Yeah, the project hardware and software were developed using Arduino, PICSimLab, and Blynk IoT mobile applications. Here, the requirements of the projects are garden lights control. We are making that temperature control, heat control, threshold temperature control, water tank control, inlet and outlet valves control, display the water volume, display the progress, and notified on the mobile Blynk app and CLCD with automatic actions. Yeah, we see the main components in our project are Arduino Uno, yeah, then PICSimLab software which is used for simulation, and we designed a Blynk app. Then yeah, about the project, yeah, in this project we used different components. They are Arduino Uno, CLCD, temperature system, Ethernet shield, serial tank, and cloud app. Yeah, these are the things, peripherals or components we used in this project. Here Arduino Uno, the main controller for processing inputs and control outputs. And we use PICSimLab. It is a virtual simulation tool used to test embedded code without real hardware. Then we designed a Blynk app it is a mobile based IoT platform that allows remote control via Wi-Fi or Ethernet. Here we use Ethernet. Yeah. Then Blynk app, a mobile based IoT platform that allows remote control via sorry. Yeah, we already discussed about Blynk app. Then we use some LEDs, light emitting diodes, and LDR sensors, and LM35, which is a temperature sensor for data collection and automation. Here we use 16 into 2 CLCD display for real-time data visualization. Yeah. Then we use Ethernet Shield for network connectivity. Yeah. Then we use PC of 8574 input output expander for extending input and output pins. And also we use serial tank setup for simulating water volume control. Each of these plays a key role in creating a realistic IoT environment. Now we can discuss about one by one by temperature. What is temperature control system? What is garden light control system? And also water volume control system. We will go through it. Yeah, garden lights control system. This functionality is garden light automation. An LDR sensor measures the surrounding light intensity. When the sunlight decreases in the evening, the system automatically switches the LEDs on, and when it becomes bright again, then they turn off. Yeah, this feature saves energy and adds convenience as the user doesn't have to manually switch on the lights every day. Here the system contains, we use Arduino Uno as we know, and the LDR sensor reads the light value and gives to the Arduino Uno, and based on the light intensity the Arduino Uno control the LEDs lights which may need to turn on or off during the sunlight and also evening. Then temperature control system. This is our next module. Here we use LM35 sensor. Yeah, used to measure temperature which is displayed on CLCD. Based on the threshold values, a heater or cooler is turned on off. If there is more amount of temperature, then we can on cooler. If there is less amount of temperature, we can on heater. Yeah. Then the same devices can also be controlled remotely using the blinking app. We can see at last end. Yeah, which allows user to manage the environment from anywhere. Here we using Ethernet, we can operate from anywhere. This system can be extended for smart HVAC or greenhouse applications. Yeah. Here we use, as we know, the main control is Arduino Uno and the Blynk IoT app, CLCD display and temperature system. Here as we know, here we use LM35 sensor. It senses the temperature in the room or anything else. Then based on the temperature, Arduino Uno controls heater and cooler. Then the temperature should be displayed on the CLCD display, and we can also control by using Blynk IoT app. Yeah, then the third module is water tank automation. The system monitors the tank water level using the serial communication and displays it on CLCD. If water level goes below the minimum threshold value, the inlet valve opens automatically to fill the tank. Once the tank is full, the valve closes to stop overflow. Yeah, an outlet valve can be operated to drain water when required. This module ensures automatic water management and prevents the water damage. Same as a temperature system, here we use serial water tank, CLCD, Arduino, and and we can operate using Blynk IoT app. Then these are the some components in our project, which include LEDs. Here we use only one LED. Then temperature system. Then yeah, this is 16 into 2 LCD display, and this is water tank. Yeah, the project implementation was done using the PICSimLab simulator, which allowed me to design and test each module virtually before combining them. And Arduino code was uploaded and executed in the simulator, and outputs was monitored in CLCD and Blynk app. Yeah, we can see it in lively. Then this is Ethernet, what we are using in this project. Then yeah, we use LDR sensor as earlier we discussed. Then we use PCF 8574 microcontroller for input and output pins expansion. Yeah, this is our project simulation and Blynk IoT app. I will show you the live. Yeah, here we use Arduino IDE for already I performed this project. So this is firstly we go through the code. This is light dependent LDR sensors .cpp file. Here I included ldr.h, arduino.h and main file. Here we use LED light as a output. That's why the pin mode garden light is output. Then I controlled then I write a code function for brightness control based on the outside intensity. The light LED sensor detects light should be on. Then this is .h file. Here we can see that LDR sensor is connected to the A1 pin of Arduino Uno and LED light is connected to the third pin. And this is main file. In main file we defined that when there is on, that is 1, and off 0, and these are temperature gauge is connected to V1, cooler pin is connected to V2, heater pin V0, like that. Then serial tank, here we can declare the volume tank and the value of inlet and outlet. This is the code for serial tank, and this is .h file. Then this is temperature system. Yeah, here also we included temperature system.h, and here setting up the pins for heater and cooler. Here heater is output pin and also cooler is also as a output pin. And this function we can read the temperature sensor value and return the temperature to the main file. Here we can control the cooler either it is on or off. Then that is temperature file .h file. Here heater is connected to the fifth pin and cooler is connected to the fourth pin, and the main code which is here. Yeah, this is here i I created a Blynk app by using. Here you can see this is my template ID and the template name is home automation. You can see further. Then the token for my this project is this one. I am highlighting. Yeah, this is token. Then yeah, these are Blynk sim Ethernet, and I am connecting including Ethernet also. Then yeah, this is our main code. Here this all code are for LCD cursor. Then this is for heater to turn on or turn off, and this main code is for inlet on or off, and this is for outlet, and this is temperature and also water volume. Yeah, here our volume of water tank is 2000 liters as we declared here. Then yeah, there here LCD initialization, and there clear set cursor in 00 position. 00 position means it is in first line, as you know. Yeah, here you are setting LCD's cursor 01, which means 1 means next line, we are printing it in next line. Then we can save the file. Yeah, I saved it and compiling it. Yeah, it's done compiling. Then we go to sketch and export compiled binary file. Yeah, I done. Then open PICSimLab, and here the spare parts I already connected that. Here LCD display and the LDR sensor, temperature system which is heater. Then I'm turning on Ethernet, and this is LED. Before going to spare parts, we need serial water tank So go to tools and open serial remote tank. Yeah, this is our tank. Here as code I connected serial tank to the COM2, so that's why I connected COM2. Then we can see this later. Yeah, then go to file and load the hex file. Yeah, this is hex file. Open it, and yeah, here as you know the code is loading. Then we open PICSimLab spare parts. You see in an LCD display home automation. Yeah, here temperature is 27.34. Here water level, we can see water tank as, yeah, I can minimize it for better observation. Yeah, sorry, this is water tank. Yeah, you can see inflow is on, water level is increasing. Before this we can check the temperature. Yeah, when I when light intensity is low, the LED is turn off. When light intensity is high, sorry, resistance is increased, that's why light intensity is decreases, that's why the LED is on. When light is more, then LED is turn off. Yeah, we can control it through the Blynk IoT app. I will connect to my phone. Yeah, Blynk IoT app. Give me a 1 minute. I will open it again. Yeah, this is Blynk IoT app. We can close this one, open this. Yeah, we can see this is our home automation project. Here you see inlet valve is on and this is on. When I can off inlet valve and on outlet valve. Yeah, you see on LCD it is displaying outlet valve on, and also water is decreasing. When it reaches to the some level, or it may be around 1800 liters, then automatically inlet valve is also on. Here we can see that this is, as we know, this is temperature system. Now cooler is, we can on heater. You see heater is on and cooler is off. Now I can on cooler. You can see that fan is rotating. Yeah, by this we are controlling with help of the home, with help of the Blynk IoT app. You know that this is heater pin, heater button, cooler button, and the temperature, how much temperature is it on. Then I off outlet valve. This is outlet valve button and inlet valve. You see that, yeah, inlet valve is on and the water level is increasing. Yeah, now I close this one. Finally, at we can go through the LDR. Here light light intensity is more, that's why the LED off. When I increases, yeah, here almost it is 81k of resistance. Then there is low temperature, lower light, then LED is on. Yeah, I will close it. Then from the project, what are the results and observations from the project? Achieved all its objectives successfully, which includes lights responded accurately to changing the light conditions. Yeah, based on light the LEDs are changing, and also we control the temperature by using heater or cooler, and also water tank controlled automatically without manual input by using the Blynk IoT app. The system performance was stable, reliable throughout the simulation. Also, I observed that Blynk app made control and monitoring much simpler and user friendly, highlighting how IoTs can enhance the daily conventions And finally, to summarize, this project demonstrates how IoT and embedded systems can be integrated to create a smart and automated home solution by using Arduino, PICSimLab, and the Blynk platform. I was able to design the system that can automatically and remotely manage essential household operations. This internship provided me with valuable experience in sensor interfacing and coding and real-time data processing, cloud communication, and IoT application design. Overall, it was a great opportunity that strengthened my technical knowledge and improved my practical problem solving skills. In future, this project can be extended further by integrating voice control using Alexa or Google Assistant, adding motion sensor for security automation, including energy consumption analytics, and deploying it on real hardware prototype for field testing. These improvements can make system even more intelligent and user friendly. I would like to express my sincere gratitude to Emerging Information Technologies for providing this internship opportunity and to my mentors for their continuous guidance and feedback. I also thank my faculty and my peers for their constant support. That, in, that concludes my presentation. Now I will move on to the already I show the live simulation part. Thank you.